In recent years, cities across the country have been designing new bicycle facilities, such as bike lanes and bike paths, to provide additional transportation options to residents and encourage increased bicycling. While providing new bicycle facilities may encourage increased bicycling, design characteristics of the street and the built environment are also important. This study examines how each of these factors are associated with bicycle use, using crowdsourced data to measure bicycle use. The study used data for the Fargo-Moorhead metro area. First, a level of traffic stress, or LTS, map was created for Fargo-Moorhead. The LTS rating is a 1 to 4 rating developed in previous studies to indicate the level of stress that a bicyclist would experience riding on that street or bikeway. Road segments and bicycle facilities were categorized based on traffic features such as road width, traffic speed, traffic volume, functional class, and the presence or lack of on-street parking, and whether bikes are in mixed traffic, bike lanes, or segregated routes. A separated bike path or a low volume, low speed street would be classified as LTS 1, while a street with high speeds and high traffic volumes with no separated bike lanes would be rated LTS 4. This shows the constructed LTS map for Fargo-Moorhead. 56% of the Fargo-Moorhead segments and pathways are classified as LTS 1, while 17% are LTS 2, 3% LTS 3, and 24% are LTS 4. Zooming in on one section of the city, we see that many residential streets are rated LTS 1, but while much of the area consists of low-stress segments, higher speed and higher volume roadways, those that are rated LTS 3 or 4, often create barriers for the low-stress network. To illustrate connectivity, we examined clusters of low-stress road segments and bike paths that are connected. This figure shows the largest clusters of connected LTS-1 facilities. An individual could ride anywhere within one of these clusters exclusively on an LTS-1 facility, but not beyond it. The edges of the clusters show where there's barriers. This extends those clusters to include LTS-1 or 2. The map shows there are some large clusters of low-stress networks, but their utility is limited if they lack low-stress interconnecting links. The factors used to calculate LTS may be important for predicting bicycle use, but other factors may also be important, such as population density, employment density, land use mix, proximity to destinations, connectivity, and demographics. The study developed a model to show how each of these factors are associated with bicycle use, using data for Fargo-Moorhead. One of the challenges for research such as this, however, is a lack of data on bicycle use. One potential solution to this data problem is the use of crowdsourced data. Crowdsourced ridership data can be obtained through fitness apps that collect data by using GPS-enabled devices. One of the more popular of these apps is called Strava. Using a GPS-enabled device, you can record the route that you rode and upload it to Strava. Strava then aggregates the data it collects from its users and creates a data product that can be used by transportation planners and researchers. One potential problem with these data is that only a small percentage of bike riders use the app, so it might not be representative, but the data have been shown to have some useful applications. This map shows the number of bike trips taken by Strava users in Fargo-Moorhead, aggregated over 2019 and 2020. The largest number of trips are taken on streets and paths that are colored red and orange on the map. These data were mapped to a grid of Fargo-Moorhead along with data for density, land use diversity, street network and bicycle facility design, distance to downtown or the river, demographics, and other variables. A model was then developed to show how each of these are related to bicycle use. Results show that the existence of bicycle facilities is positively associated with bicycle use. So that suggests that bicyclists are using the roadway design features that were meant to accommodate them, and that investments in these facilities have been useful. The results also show that each type of bicycle facility had a positive effect, even the shared lane markings, the signed-only routes, and the shoulders, although the effect was greatest for shared use paths and bike lanes. Connectivity was also shown to be important. Areas within a larger cluster of connected low-stress streets or bike paths had higher levels of bicycle use. And bicycle use was also found to be greater in or near downtown and in areas near the river. These are popular attractors of bicycle use, so the findings support development of bicycle infrastructure in these areas. Areas with higher traffic volume and speed surprisingly had greater bicycle use, even though these are higher stress areas. The result could be due to bias in the data if the Strava users are not representative, but it also suggests that there's demand for bicycle use along these routes. The research provides information to transportation planners regarding barriers in the bicycle network and the effectiveness of investments in and design strategies on encouraging bicycle use. And it also shows how emerging crowdsourced data could be used to supplement traditional data sources in understanding bicycle use within a city. For more information on this research, visit our website or contact me. My name is Jeremy Madsen. I'm an assistant professor at North Dakota State University. I work with the Small Urban and Rural Center on Mobility, or SURCOM, which is a program of the Upper Great Plains Transportation Institute at NDSU. At SURCOM, we provide research and education for improving mobility in rural and small urban areas. Visit our website for more information about this research and other research projects, as well as our education programs and training opportunities.